Every road tells a story of engineering, movement, and human progress. Some roads cut through mountains, some rise above cities, some cross deserts, coastlines, and remote landscapes. And behind every one of them is a carefully planned system of design, strength, safety, and purpose. From massive highways to smart roads of the future, each type of road is built to solve a different challenge in transportation. In this video, we are exploring 30 major types of roads, not just what they are, but how engineering transforms terrain into connection, speed into structure, and ideas into infrastructure. Highway road. We begin with the highway road, one of the most important arteries of modern transportation. Built to carry large volumes of traffic over long distances, highways are designed for efficiency, safety, and endurance. With engineered pavement layers, shoulders, medians, drainage systems, and high-capacity geometry, the highway is far more than a road. It is a backbone of regional and national connectivity.
The highway stretches across the open landscape, a vital artery moving traffic smoothly towards the horizon.
Expressway, but when traffic demands even greater speed and fewer interruptions, the design evolves. That is where the expressway comes in. An expressway is built for uninterrupted movement, with controlled access, limited entry points, and grade-separated interchanges. In engineering terms, it is a high-performance corridor designed to reduce conflict points, improve traffic flow, and move vehicles quickly and safely through major transport routes. Motorway, and beyond the expressway lies an even more controlled and advanced road system. The motorway represents one of the highest standards in road engineering. Fully access controlled and designed for high-speed travel, it includes multiple lanes, emergency shoulders, central medians, and strict operational control. Every detail, from pavement durability to alignment design, is planned to deliver maximum capacity, safety, and long-term performance. Urban arterial road, but not all roads are built for distance. Some are built to keep entire cities alive. An urban arterial road is a major city corridor that carries traffic between key urban zones. It connects residential districts, business centers, and industrial areas through a carefully engineered system of signals, medians, intersections, drainage, and pedestrian facilities. In the urban environment, the arterial road becomes the framework that supports daily movement and city function. Collector road. Between major city roads and small local streets, another link quietly performs a vital job. That link is the collector road. Designed to gather traffic from neighborhoods and channel it toward arterial roads, collector roads create balance in the road network. They are engineered to support moderate traffic flow, organized access, and safe distribution between local mobility and larger transport systems. Local street road, and at the most immediate level of daily life, roads become more personal. A local street road is where transportation meets direct access. It serves homes, shops, and nearby properties, carrying low speed and low volume traffic in neighborhood settings. Here, engineering focuses less on speed and more on accessibility, drainage, pedestrian safety, and utility coordination within the built environment. Rural road. As cities fade away, roads begin serving a different kind of purpose. A rural road connects remote communities, villages, farmland, and open countryside. These roads may appear simple, but their importance is enormous. They support agriculture, local trade, education, and wheelchair access. In engineering, rural roads are shaped by terrain, soil conditions, traffic demand, and cost efficiency, often using practical yet highly functional design solutions. Mountain road, but when the land begins to rise, road engineering becomes a battle against gravity. A mountain road is built through steep, unstable, and challenging terrain where every curve and slope must be carefully controlled. Engineers must deal with rock cutting, retaining walls, drainage, erosion, and slope stabilization. In these environments, the road is not only a transport route, it is a precise act of engineering against the forces of nature. Hill road with hairpin bends, and when steep slopes leave no room for straight movement, geometry takes over. Hill roads with hairpin bends are designed to safely overcome major elevation changes within limited space. These tight turning sections reduce road gradient and allow vehicles to climb or descend mountainous terrain with control. Their design requires careful attention to turning radius, slope stability, drainage, and roadside protection. Desert road from mountains. The challenge shifts to heat, sand, and endless exposure. A desert road is engineered for one of the harshest environments on Earth. High temperatures, shifting sand, and long isolated stretches demand durable pavement, strong visibility, and climate-resistant design. Engineers must consider thermal stress, sand encroachment, and maintenance access to keep desert roads functional under extreme conditions. Coastal road, and where the land meets the sea, roads must resist an entirely different force. A coastal road runs beside shorelines where moisture, wave action, erosion, and salt exposure create constant engineering pressure. These roads often require embankment protection, seawalls, corrosion-resistant materials, and effective drainage. A coastal road is where transportation engineering and environmental defense work side by side. Concrete road, terrain is one part of road design, material is another. A concrete road is a rigid pavement system built for strength, durability, and long service life. It distributes wheel loads over a broader area and performs well under heavy traffic conditions. In pavement engineering, concrete roads are valued for structural stability, reduced deformation, and long-term performance where maintenance access may be limited. Asphalt road, but in many parts of the world, flexibility becomes the preferred engineering solution. An asphalt road is one of the most widely used pavement systems in transportation infrastructure. Known for its smooth surface, faster construction, and easier maintenance, asphalt roads are built using layered flexible pavement design. Engineers optimize compaction, thickness, drainage, and material quality to achieve strength, ride comfort, and durability. Gravel road. Not every road needs a fully paved surface to perform its function. A gravel road is a practical and cost-effective solution for low traffic and remote areas. Constructed from compacted aggregate materials, it depends on surface grading, crown formation, and drainage control to remain stable. Though simple in appearance, a well-engineered gravel road is the result of thoughtful material and maintenance planning. Earthen road, and at the most basic level of road formation, the ground itself becomes the roadway. An earthen road is formed mainly from compacted natural soil and is often used in rural or undeveloped regions. Its performance depends heavily on soil type, moisture condition, compaction, and drainage. In engineering terms, it is the most basic road form, yet in many places it remains an essential first step in connectivity.
As the compactor moves slowly, the grading patterns and drainage cuts ensure the stability of the newly formed earthen road.
Brick paved road. Sometimes the road surface is designed not only for movement, but also for texture and character. A brick paved road uses masonry units arranged in a patterned surface, often in low speed areas, traditional streets, or heritage settings. Engineers design these roads with proper sub-base support, joint spacing, and edge restraint to ensure the surface remains stable under load while preserving its visual identity. Interlocking block road, and when modular construction meets pavement design, flexibility takes a new form. An interlocking block road is built from precast paving units that fit together to create a durable and maintainable surface. Widely used in residential streets, urban spaces, and parking areas, this system is valued for its neat finish, easy repair, and adaptability to underground utility work. It is a practical blend of engineering performance and urban design. Service road. As major roads grow faster, supporting roads become essential. A service road runs parallel to a main highway or arterial corridor, providing access for local traffic and nearby developments. By separating local movement from high speed through traffic, service roads improve safety, reduce conflict, and strengthen corridor efficiency. In transport planning, they play a quiet but critical role. Ring road. When cities expand, traffic needs a way to move around them, not through them. A ring road is designed to encircle a city and divert through traffic away from the urban core. It reduces central congestion, supports freight movement, and improves network efficiency on the city's outer edges. From an engineering and planning perspective, the ring road is a strategic instrument of urban traffic management. Bypass road, and where direct urban entry creates delays, a simpler solution emerges. A bypass road redirects traffic around built up or congested areas, allowing long distance vehicles, especially heavy transport, to continue without entering the town or city center. Engineers design bypass roads to improve flow, reduce travel time, lower urban pressure, and enhance transport efficiency across wider regional networks. Flyover road, but when horizontal space is limited, the road begins to rise. A flyover road is an elevated traffic structure built to cross intersections, rail lines, or congested corridors without interruption. It is a major feature of urban traffic engineering, combining roadway design with structural systems such as piers, decks, foundations, and expansion joints. Flyovers create vertical solutions for horizontal congestion. Underpass road, and while some roads rise above conflict, others move below it. An underpass road passes beneath another route or structure to maintain uninterrupted movement. It reduces crossing conflicts and improves traffic continuity in dense transport environments. Engineers must carefully design underpasses with retaining walls, drainage pumps, lighting systems, and structural protection to ensure safe operation below grade. Tunnel road. Then there are roads that do not go around obstacles, they go through them. A tunnel road is one of the most technically demanding forms of transport infrastructure. Built through mountains, hills, or beneath major obstacles, tunnel roads require excavation planning, structural lining, drainage systems, ventilation, lighting, and emergency safety provisions. They are a remarkable example of engineering precision in confined and complex conditions. Bridge approach road. Even the connection to a structure can be an engineering challenge of its own. A bridge approach road is the section that links the normal roadway to the bridge deck. Though often overlooked, it is essential for smooth and safe transition. Engineers design approach roads to manage embankment support, settlement control, alignment continuity, drainage, and structural integration with the bridge itself. Industrial road, and in places where roads carry industry, the pavement must carry far more than traffic. An industrial road is built for warehouses, factories, freight yards, and logistics zones where heavy vehicles operate continuously. These roads demand stronger pavement layers, durable shoulders, and reliable drainage to withstand repeated heavy axle loads. In engineering, industrial roads are designed for performance under pressure. Airport access road. Some roads are not only about movement, they are about organized movement. An airport access road connects urban transport systems to terminals, service areas, and aviation infrastructure. It must handle public traffic, drop-off zones, buses, taxis, and service vehicles with precision and clarity. Engineers focus on lane organization, traffic circulation, signage, and safety to maintain efficiency in one of the most dynamic transport environments. Bus rapid transit road. As cities seek faster mobility, road design begins to prioritize public transport. A bus rapid transit road is a dedicated urban corridor designed for high-capacity bus movement. With exclusive lanes, station platforms, controlled intersections, and efficient boarding systems, BART corridors improve speed, reliability, and mass transit performance. It is a road system engineered not just for vehicles, but for urban mobility itself. Slip road / ramp road, and where roads intersect at speed, connection must be carefully controlled. A slip road or ramp road allows vehicles to merge into or exit from another roadway safely and smoothly. Common at interchanges and motorway junctions, these roads depend on curvature, speed transition, superelevation, and merging distance. Their geometry is critical in maintaining both safety and traffic flow. Temporary construction road. Even before permanent infrastructure is complete, roads are needed to build the future. A temporary construction road provides access for labor, machinery, and materials within a project site. Though not permanent, it must still be engineered for load-bearing capacity, drainage, and operational safety. These roads are essential to construction logistics and play a major role in keeping complex projects moving efficiently. Smart road / future road, and finally, road engineering moves into the future. A smart road combines traditional pavement engineering with digital technology and intelligent transport systems. These roads may include embedded sensors, adaptive traffic controls, connected vehicle communication, and autonomous guidance features. Smart roads represent the next step in infrastructure, where data, safety, and mobility are integrated into the roadway itself. Iantly, from the simplest earthen track to the most advanced smart corridor, every road is a product of engineering purpose. Each one is designed to respond to a specific need, terrain, traffic, speed, safety, economy, or technology. Roads are not just surfaces for movement. They are systems of planning, structure, materials, geometry, drainage, and design. They connect cities, support industries, open remote regions, and shape the way the world moves. And behind every successful road is the unseen intelligence of civil engineering,